Hello, my name is Nishan Deka. Today I am going to make a short video on the subject Internet of Things. In the subject Internet of Things, there is a topic called agriculture and agricultural use of IoT. So in the agricultural use of IoT, there is a uh, part of irrigation, with the use of IoT, we can name it as smart irrigation. So as we start, as you can see in the three graphs, one is of developing and poor countries, one is the world average, and one is the developed countries. So there is the or the brown part is the industrial use of water, uh, and and in the dark blue part that is the domestic use of water, and the light violet type of part you can see that is the agricultural use of water as a whole. So, as a whole in the world, there is the agricultural use of water is 70%. But in poor and developing countries, so like India is a developing country. So here the uses of water in agricultural use is very high uh, as compared to developed countries, which is only 30%, like America, Russia, France, like that, developed countries. But since in our country, India is a developing country, so we need a high percentage of water for agricultural use. So as you can see in the graphs, so now there are two types of irrigation systems. The earlier one we used was traditional irrigation system, which has been there for a long time. So here the farmers have to go to the farm, the field, and they have to physically check the soil moisture level. They then turn and off the irrigation systems to provide water to the crops. So that they have to go and physically and manually check. That can be very time consuming and labor intensive. But in IoT based smart irrigation system, there are some IoT devices, which are placed in the field, which sends the soil moisture level, weather condition, plant growth, and data that is collected to the center is sensor is sent to the cloud-based platform. That means a server. As you can see in IoT, there is a server, main server, where it is analyzed and without means the farmer don't have to go and check manually. With the as the sensors themselves they sense the data and send. So according to that, the motors will work, the irrigation system will work. So this is the basics of IoT-based smart irrigation system. So benefit of smart irrigation is that after any implementation of smart irrigation, we have seen maximum crop yield increase up to 230%. That is too much. We have seen too much crop yield increase percentage, and it also saves water up to 70% because since it is not manual, you can save wastage of water. So it also saves water. Okay, crops also grows consistently healthier because manually, if sometimes there might be uh, by mistake the water might come more than what is needed, so crops may get damaged. But in smart irrigation, the crops are also healthier. Human efforts has also reduced this, and and we can also have a unified view of the unified view. That means all the factors that is affecting the crop growth, we can unify them and view as a whole. And it is also long term for better for long term landscape health because in manual irrigation, after a few of years, after 10 years, the health of the land might get deteriorated. But due to smart farming, the health of the landscape is also that is it is also uh, increased. The health is increased, and also there are some um, terrains like which are not earlier. There are some terrains which are not perfect for irrigation. So using the manual techniques, we cannot irrigate crops on the terrains, like hilly, waterlogged, saline area. But after the introduction of smart irrigation, we can also grow crops on those lands. That is one advantage. The types of smart irrigation systems, there is a weather-based irrigation system, there is a volume-based irrigation system, there is a time-based irrigation system. In the weather-based irrigation system, yeah, these systems collect the real-time data of the weather, temperature, rainfall, and according to that data, they adjust the flow of water in the machines and they adjust the irrigation schedule. So, if there is, for example, if there is a forecast of rain, the system will reduce the amount of water it applies to the plant. So, it can help the farmers to save water like that. And there is a volume-based irrigation system in which the sensors measure the volume of water applied to the plants. So, if we measure the volume of water that is applied to the plants, we can be more accurate that we don't give the more the water than needed or less than the water that is needed. So we can be too much accurate about the percentage of water. So this is the volume-based irrigation system, and the time-based irrigation system is here. We that means we can uh, preset the irrigation schedule. That means we want the water to be released at night 9 p.m. So in the time-based irrigation system, if we pre-schedule it, that every night at 9 p.m. the irrigation process will begin. It will follow the fixed schedule, and it will always plant the water at 9 p.m. So this is the time-based irrigation system. Components used in smart irrigation system are sensors, gateways, cloud-based servers, irrigation controllers, and mobile application. And you know the sensors, they collect that data. Uh, there are many kinds of sensors like weather sensor, moisture level sensors, temperature sensors. In a gateway, gateways are used to transfer the collected data from the sensor and transfer to the central server. So for that, gateways are used. So gateway may be generally it is wireless, but we used LoRaWAN or Wi-Fi technology. So this is the gateway. And the cloud-based server is the central server where the collected data comes from the sensor to the gateway to the cloud-based server. And upon the data, we analyze and process the data to give the outcome, the outcome as per the that data. Irrigation controllers are used on the field, which automate the irrigation process based on the data output data given by the cloud based. And finally, the mobile or web-based application. It is an application that is being used by the farmer themselves. So, by using this application, they can change the flow of irrigation and change the system by sitting at their home only. They don't need to go to the field. So these are the components. Now, LoRaWAN is a technology which is used in irrigation. LoRaWAN is a large range wide area network. It is low power, but it covers a large range of network. So it is especially useful in irrigation because in irrigation terms we need a large and long range communication. Although it will have a low power consumption, it is one of the advantage low power consumption and large network. So LoRaWAN is used in irrigation. So LoRaWAN also has the special ability that there are some unauthorized frequency bands which are not legal in some parts. But with the use of LoRaWAN, LoRaWAN can operate on that frequency bands also. So, so it is useful in large, difficult terrains for irrigation. So as you can see, this is the LoRaWAN diagram. Temperature sensor, soil sensor, weather sensor. All it covers the all large part of the area using the LoRaWAN. So at last we will see the barriers that in the smart irrigation system. One is the cost, first one, because since India is a developing country, many of the farmers don't have the money to implement these IoT devices and these IoT facilities in irrigation. So that is the main problem: cost of the materials for irrigation, especially in India, in developing countries. And there's a technical complexity since in developing countries like India, farmers are not well educated, so they don't have the technical knowledge about the devices. So there's a less technical knowledge among the farmers. There is also a problem of data accuracy and reliability, because if some sensors give wrong information or if the sensor is faulty, then the data we will get is inaccurate. And it may result in harmful consequences like many like if the water is not needed to be plant, but still the water is going on. So it will affect the crops in large scale. And there's the problem of connectivity. In difficult terrains, there is also a problem of connectivity, especially in India. And there is regulatory barriers like the legal and non-legal bandwidth. So there are the regulatory barriers and resistance to change. This is the main prominent reason that many of the farmers they have been using the traditional irrigation system. So um, they are resistant to change. They don't want to change. They want to be the, because if they want they will change, they will have to learn new technical terms about the devices, IT devices. So they don't want to change. They want to keep the traditional technique. So this is the problem in their mindset to change the techniques of irrigation. So this is the basic irrigation system. So you can see IoT devices used in agriculture, soil sensors, passive infrared sensors, Arduino, radar station, livestock monitoring system, drones, smart tractors, crop management software. So these are the devices used in agriculture. So thank you. This was my part of this short video on Internet of Things. Thank you.